Hey, Mr. McNeil, it's Farhan, Period 2 Honors Physics. I'm here to talk to you for about 10 minutes about something that has to do with physics. So I'm going to talk to you about the history of the metric system. Let's get started. So the metric system was an internationally agreed set of units for measurement, and since 1960, the metric system is correctly known as the SI system, which is short for Système International de Units. However, it is still commonly continued to be referred to as the metric system. It has only 7 basic measures known as units. I'm going to tell you about them. So, the type of measure starting off would be, let's start with length. The standard unit would be a meter, the symbol being m. The type of measure for mass, which is weight, the standard unit is kilogram. The symbol would be kg. The type of measure for temperature is a degree Kelvin, and the symbol is K. Time would be measured, the standard unit would be a second, and the symbol would be S. Electric current would be measured by amperes, and the symbol would be A. The amount of substance to measure that would be measured in a mole, and the symbol for that is MOL. And the type of measure for luminous intensity would be measured by the term candela, and the symbol is, I believe, CD. I think so. So then we're going to talk about the kilogram. So although the kilogram is commonly used as a measure of weight, it is actually defined as a measure of mass. Weight is a measure of how heavy something is, where mass is a measure of the amount of the matter. To illustrate, a 120-pound woman would weigh only 20 pounds on the moon, due to the moon probably having lower gravity or something, you know. Just kidding. So, where maybe a woman who weighs about 150 pounds would be about 150 pounds on both the Earth and the moon. In other words, her weight, or how heavy she is less on the moon, but her mass, how much matter she has, is unchanged. For everyday use, the difference between mass and weight is irrelevant, as everyone is together on Earth. However, for scientific calculations, the difference is important. Let's talk about temperature. Also, the temperature is officially measured in degrees Kelvin, but in day-to-day use, the Celsius system is also used as well. The original metric measure of temperature was the Celsius system, where 0 degrees Celsius was set for the freezing point of water. Officially, this has now been replaced by the Kelvin system, where 0 degrees Kelvin is set to absolute zero. So, however, it is more, it's more natural to say, what a hot day, it must be 40 degrees Celsius, than to say, what a hot day, it must be 313 Kelvin, It would just make more sense. So, consequently, the system Celsius lives on a common usage. The key to the simplicity of the metric system is in its use of multiples of 10, and its reliance on only 7 different base units. These units can be then combined to make other measures. For example, speed can be expressed as meters per second or volume in terms of cubic meter. There are also some variations in spelling. In some countries, the unit of length is spelled meter, M-E-T-E-R, while the other is spelled metre, or meter too, but it's M-E-T-R-E. Likewise, the unit of volume may also be spelled liter or liter, and abbreviated to capital L or lowercase l. So you want to talk about metric prefixes now. So in the metric system, the standard units of measurement are multiplied by 10 or divided by 10 in order to produce larger or smaller units. For example, a decimeter is a tenth of a meter and a decameter is 10 meters. For even larger or smaller units, one continues to divide or multiply by 10. So for example, one could say either 1,000 meters or one could say a kilometer, as kilo means 1,000, which is 10 times 10 times 10. So the following table lists all of the prefixes that I'm going to talk to you about. This use of base 10 greatly simplifies calculations and is a major reason that the metric system has been so widely adapted. A simple illustration of this is to first measure the room in yards and inches and calculate the amount of required carpet in square yards. Then repeat the measurement in meters and centimeters to calculate the amount of carpet in square meters. The latter calculation is far quicker and simpler. One can either use the multiplication prefix combined with the measurement, kilometer, or the multiplication symbol combined with the measurement symbol, or kilometer, or km. So, combining a symbol with a non-symbol, k-meter or kilo-m, is not done. So for let's talk about the multiplication factor, scientific notation of these measurements. So, let's start with 10 to the 24th power. I didn't memorize these, I'm reading this list right here. 10 to the 24th power, the prefix would be yada, and the symbol would be a capital Y. 10 to the 21st power is a zeta, and the symbol is a capital Z. 10 to the 18th power would be called an exa, which is a capital E. 10 to the 15th would be a peta, which starts with a which the symbol would be capital P. Now 10 to the 12th is a tera, and that symbol would be a T. But then you have bigger numbers like 100 million, 1 billion actually. Let's go with 1 billion. 1 billion would be a giga, which is G. 1 million would be a mega, which is capital M. 1,000 would be a kilo, which is K. 100 would be a hecto, which is H, and then a deca would be DA. But then going down negative, you would go down to 10 to the negative first, which is 1/10, would be deci, lowercase d. 10 to the negative second power, centi, which is a lowercase c. 10 to the negative third, milli, which is m. And then you have micro, which is 10 to the negative fifth. And the symbol... It's an ugly little thing, isn't it? It looks like a upside down H, upside down lowercase h, doesn't it? Doesn't it, Mr. McNeil? Look at that. Oh, wait, never mind. So then 10 to the 9th power in negative, 10 to the negative 9th is a nano. And that's getting really small, and we're getting a lot smaller as we go down. So let's go down to a pico, 10 to the negative 12th power, which is a p, lowercase p. 10 to the 15th power, that's a small unit, femto, which is f. 10 to the negative 18th power, atto, that's a lowercase a. 10 to the negative 21st, zepto, which is z. And probably as small as I'm going to go here, 10 to the negative 24th, yocto, which is a lowercase y. And that's really small. I mean, we're going down to microscopics right there. So, I mean, yocto, that's about as small of measurement as you can possibly think of. So, let's talk about the history and the basic definition of what a meter is. Let's start with where it's derived from. The word meter is from the Greek word metron, which means a measure. At the time the metric system was being defined, there were two competing approaches to the definition of the length of a meter. The initial suggestion was that it be the length of a pendulum having a half period of 1 second. The alternative approach was to set it to 1/10 millionth of the length of the Earth's meridian along a quadrant, the prime meridian. So, specifically, 1/10 millionth of the distance from the North Pole to the equator, along the meridian running near Dunkirk in France. The French Academy of Science, which was tasked with developing the metric system, decided on the latter approach in 1991 on the basis that the former approach does not have a consistent measure, as slight variations in the Earth's gravity from one place to another would result in different values. The distance was calculated with a slight error, as the inflating of the Earth due to its rotation was not taken into account, and a brass bar of metal was cast to this length. This metal bar was then used as the standard. Since then, although the length has remained constant, several changes have been made to the definition in order to increase the precision of the measurement. First, this involved replacing the brass bar by a platinum bar, and, subsequently, a platinum iridium bar, and specifying conditions, the temperature, for example, under which the bar is stored. Later, for even greater precision, the definition was changed to reflect constant physical phenomenon rather than a metal rod. The following table I'm going to read now summarizes the major changes. The definition since 1983 is accurate within 2.5 times 10 to the negative 11th. So, let's go down. I'm going to read you the various definitions of a meter throughout the years. Okay, the definition of a meter in 1793 was 1 divided by 10 million, 1/10 millionth of the distance from the pole to the equator. That's it's pretty complicated there. They went in great depth to get that definition there. In 1795, only 2 years later, of course, the provisional meter bar constructed in brass defined the meter. In 1799, definitive prototype meter bars constructed in platinum were the definition 4 years later. 1989, however, 90 years later, International Prototype Meter Bar and Platinum Iridium in the cross-section S were used to define a meter. 1906, however, I believe 1 million divided by 0.643849696 wavelengths in the air of the red line of the cadmium spectrum. So they were really getting their stuff down right there. Am I right? Am I right? In 1960, 54 years later, they used, I believe, 1,650,763.73 wavelengths in vacuum of the radiation corresponding to the translation between levels 2p10 and 5d5 of the krypton-86 atom. But then 23 years later, how we define a meter now will be length traveled by light in vacuum during 1 divided by 299,792,458 of a second. So I mean that's about as in detail as you can get about a meter. So that's the meter right there. I'm just gonna check my time right now. Oh wow, I'm in 11 minutes. Well, how about I keep going? How does that sound? Extra credit, maybe? Alright, let's try that. So, let me try the history and definition of a gram and a kilogram, and then I'll wrap up here. So, a gram was initially defined as a cubic centimeter of water at its temperature of maximum density, which would be 4 degrees Celsius. Likewise, a kilogram was defined as a cube decimeter of water, a cube 0.1 meters on each side, which is 1,000 cubic centimeters for 1,000 grams. This mass, weight, has been reproduced in metal weight, platinum and iridium, or platinum iridium, which is now used as the standard. In other words, a kilogram is no longer officially defined in terms of the mass of a volume of water, rather in terms of the mass of the corresponding official metal weight. Accordingly, a gram is now defined as 1/1000th of this metal weight, rather than in terms of a cubic centimeter of water. So, there we go, there we have it. I went in about 10 minutes. I'm probably in at about 11 or 12 right now, 13, something like that in the time. But I think that wraps up my discussion here, and I hope you enjoy it, Mr. McNeil. And now I'm going to wrap this up.